Hello, my name is Ardi and we are going to solve problem 4.11 from Sadiku book. So the question is, use the superposition principle. We are asked to use superposition to find I0. I0 is this one and V0. V0 is this one. And let's recall the concept of superposition principle. So what we need to do when we are superposition. Okay, so the first step is to break down into two or more circuits. So two or circuits. How? By turning off each independent and sources. And we need to take a look at our sources here. We have three sources. Two are independent, so this 6 ampere current source is independent and this 30 volt is independent source, but this one is dependent current source, so we don't need to turn off. So we need only to turn off this current source and we need to turn off this voltage source. And how to turn off current source? So current source is becomes open circuit, and then voltage source becomes short. Okay, and then after breaking down into two or more circuits, we need to analyze both of them. So analyze all of them one by one or separate, and we add up all the results. Okay, now what we need to do here is replace this one by open circuit in the first circuit, okay, and replace this one into it in the second circuit. Okay, now let's break it down into two. So this is the circuit number 1 and circuit number 2. So here I replace this 6 ampere current source with an open circuit, so I did not draw it anymore. And then in this circuit number 2, I replace this 30 volt voltage source with a short circuit. So we have two circuits, circuit number 1 and circuit number 2, and we need to analyze it separately. And let's start analyzing circuit number. Okay, now we have this one, and I will pick this node here as our ground, and I will name this differently. So I want to rename this as V0 prime, and this one is I0 prime. And then I want to use KCL at this node. Let's name this node as A, right? Okay, let's see, KVL at node A. And what does KVL says? KVL says that the sum of the currents that goes in is equal to the sum of the currents that goes in, right? Should be obvious. And let's assume the direction of the current. We are given here as I0, and then this one here, maybe I will assume that the direction will be there, And for this one, it's not here because this is minus 30 volt from ground, so this is okay. Okay, now let's check the current that goes in. There are two currents that goes in. This one is I0, and from this for I0. Okay, so I will write that I0 plus 4I0, then that will equal to the current that goes out. There is only one current that goes out, which is this one, and that one is VA minus 30 divided by the resistance between, which is 20. Okay, now I will have 5I0 will equal to VA plus 30 divided by. Okay, now what we need to do is find out which is I0. I0 is this node, right? And minus this VA divided by 50. I will have 5 multiplied by 0 minus VA, which is minus VA. Okay, divided by 50. And that will equal to VA 30 divided by. Okay, now this 5 and 50 will cancel into. Okay, then what can let's do some simple algebra. I will have minus 20 VA is equal to 10 VA B, or I will have 30 VA is equal to minus E, or that means that VA is equal to minus what? 1. So this is for VA, and when VA is minus 1 volt, we can easily calculate I0. But here we have I0 prime, right? I'll have I0 prime is equal to 0 minus V divided by, what is it, 50. So I will have I0 prime will be 0 minus 1 divided by, or that will equal to 1 over 50 what? 1 over 50 or maybe we can rewrite this as 1000 divided by 50, which is 20. Okay. Now if I0 prime is 20 milliampere, we can just calculate this V0. But here we have V0 prime will equal to I0 prime multiplied by the resistance, which is 10. So I will have 1 over 3 multiplied by 10, or I will have 10 over T, which is 0. So I now have I0 prime and V. Okay, let's save this value. So I will have 0 prime here, and I will have. Now we have done for circuit number 1, and the next step we need to do is analyzing the circuit number. Okay, now we have this circuit number 2, and let's name that V0 and I0 on this circuit as V0 double prime and I0 0. Okay, so we need to use different name then. And what can we do from here? Maybe I will use nodal analysis. Okay, circuit 2, and let's name this node here as node, and let's name this node here as node E, right? We need to do KCL at both nodes, so maybe I will assume the direction of the current first. So this is going to the node, and want this to go down, and then this will go to the right. Okay, this will go to the right. See if we can. Let's use KCL at node A. Remember that we have to specify on here. This one will be on. And then KCL said that the sum of the current that goes in is equal to the sum of currents that go out. Okay, the sum of the currents that goes in. In node A, there is only one current that goes in, which is this 6 amp. Okay, so I will just write 6 here. And then there are 2 currents that goes out. The first one is this one, and the second one is that is going to the right. For this one, I will have VA over 40. VA over 40. And then plus VA minus VB divided by 10, right? We'll have VA minus VB. Okay, so now what can we do here? Maybe I will just like this. What? 120? Okay, maybe 120 is fine. I will have 2,720, and this one I will need to multiply this by 3, right? I have 3 VA. For this one I will need to multiply this number by 12. Okay, so I will have plus 12 VA minus 12. Okay, so I will have 120. E is equal to 4 VA minus 12. I think I can simplify this by dividing both sides by, oh, this is not 4, right? That is should be 15. But yeah, I still can simplify this maybe by dividing both sides by 3, right? So I will have 5 VA minus 4 VB. 120 divided by 3 is 200. Okay, now let's save this as equation. And now let's do another KCL but at B. Okay. So similarly, the current that goes in is equal to the current out. There are 2 currents that goes in, and this is this one, right? So I will have VA minus VB divided. This current here also going inside the node, but this one is for IO, right? So I will have plus 4, but I0 is the same as this one, right? I will have 4 VA minus VB divided Okay, and the only current that goes out is this, which is VB divided by. Okay, let's simplify this one. I will have 5 VA minus 5 VB divided by 10, and then that will equal to VB divided by, and we can multiply both sides by what? 20, right? By both sides. So I will have 10 VA minus 10 VB is equal to V, or we need to make this 10 VA is equal to 7, or in other words, VA is 1.1 multiplied by. Okay, let's name this as equation number 2, but we can just plug this VA into equation number 1. So let's do it here, but I will use divisor. Let's see, we'll have 240 is equal to 5 multiplied by 1.1, okay, minus 4V. Right? So I will have 240 is equal to 5.5 minus 4VB. Minus 4VB means that we'll have 1.5. So I will have VB here is equal to 240 divided by 0.5, or maybe I will need to use my calculator. 150 divided by 1.5, that will be 160 volt. And that means that VA is 1.1 multiplied. So I just need to multiply 160 with 1.1, and that means that VA is. Okay, now from this fact we can calculate V0 and I0, right? So let's use here. So V0 double prime is just VA minus VB, right? VA and VA is 106 minus V, which is 103. I will have V0 double prime is equal to 4. Okay. Now this is an important value, and the second value that we need is I0 double. So I0 double prime here is just VA minus VB, which is 16 volt, divided by 10, or I will have 1. So now we have the important values here, I0 double prime and V0, and we need to add up with 1. Okay, let's make a new slide. So we have a fresh slide here, and remember that V0 is equal to V0 prime plus V0 double prime, and I0 is equal to I0 prime plus I0. Okay, now let's see what is V0 prime and V0 double prime. V0 prime is 0.2 volt, and then V0 double prime is 16 volt. So I will have 0.2 volt, and this one will be 60 volt, or that will be 16.2. So this is for V0, and then for I0 we will have I0 double prime and I0 prime plus I0 double. I0 prime is 20 milliampere or 0.02, right? So I will have 0.0 ampere plus I0 double prime. I0 double prime is 1.6. 1.6 ampere. So I will have 1.62 ampere or, and in conclusion we have this V0 and then I0 from superposition. So hopefully this will help you to solve this. Thank you. Bye bye.